In this video, we will be talking about organic compounds and functional groups. I can assure you that this is going to be an incomplete discussion, but I suppose that the specific functional groups that I will present to you would teach at least a general knowledge in regards to functional groups. This is what I've studied in 10th grade, or in other words, 4th year high school. I just wanted to share this to you. Those students were also 10th grade or in grade 10. Okay, without further ado, let's start. So, functional groups. Let's start with the first three structures that I've learned. So we have alkane, alkene, and alkyne. What makes these three words different, or these three terms in functional groups? This lesson is closely related to our concept in the next lesson after this. Basically, ANE means one carbon in the substituent. I know that this topic is still complicated to just say it that way, but I'm sorry. This is not the substituent. The parent, one carbon in the parent structure of the functional group. We will discuss that in future videos, but as for now, we have to pay attention to how we draw the structures. These structures, in terms of drawing, may vary. Structures can change literally in structure, but the numbers of carbons and hydrogens, I suppose, remain the same. We just have to look closely, specifically for alkane, alkene, and alkyne. What matters is that I really have to break this down to you now. Alkane, we only have a single bond. Alkene, we have a double bond. Alkyne, we have a triple bond. 3 lines. Let's show that right now. So we'll start with alkane. C, 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 C. So this is how we draw alkane. Again, the structure may vary, but this is what was presented to our lecture in our school. So basically, we have 4 carbons in the middle, and surrounding everything in it is the hydrogen. Let's move to alkene. Alkene this time has 5 carbons, and this is where we just have to outline every line that could be possible, that could stick in either east, north, west, and south of the carbon. Basically the up, down, left, right. And we'll have to disregard these two because they're both linked by the equal sign. In other words, the equal sign refers to double bond, as I have said earlier, because double bond refers to E and E. And I suppose Y and E refers to triple bond. Anyways, back to alkene. Hydrogen, 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 hydrogen. You have to surround everything with hydrogen. So there. I apologize. The outline looks ridiculously imperfect, but this is how we draw it. 5 carbons in the middle, and beside the 2 carbons at the relative left, at the relative right, in your side, we have to place the equal sign, which resembles the double bond. And everything else, just like alkene, the carbons will be surrounded by hydrogen, whilst the carbons in the middle, the ones that are linked by that are put together by the equal sign, they won't have carbons at the top. So this will leave us blank. So yes, let's just fix, let's not make confusion. Let's move alkane at the bottom and move alkene here. Let's make a considerable chasm among the outlines. So this is what we have for alkane, this is what we have for alkene. Let's move to alkyne, triple bond. We're back at having 4 carbons like alkane, and we link them together this way. Then we have the triple bond sign at the middle, the very middle, connecting the 2 C's. Now let's place our hydrogens at the edges of the structure, the carbons at each edge, left and right, and we'll leave this without hydrogen at the north and south, or at the top and the bottom, because we have the triple bond sign. Just like what we have for alkene, because of the double bond sign, these carbons are not able to have connection with 2 hydrogens, supposedly, unlike alkene. And that kind of concept also goes for alkyne. And I might be mistaking in this, but I suppose I can propose a hypothesis that the reason why we don't have carbons both up and down on these, we don't have hydrogens on these 2 carbons at its up and down, is that because alkyne has 3, it's a triple bond. It comprises of a triple bond, and for alkene, it only comprises of a double bond. So we can still have 2 hydrogens at the bottom, but provided that we have triple bonds, we can't really add the hydrogen there. That's just my hypothesis. I might be wrong, but I suppose that there's some point in that kind of argument. But anyways, this is everything that we have to remember for alkane, alkene, and alkyne. We have to note ANE, ENE, and YNE. Those suffixes will be tackled later in the video. Let's move to the next chapter. We have alcohol. We have aldehyde. It's another variant of alcohol, but there's one difference that differentiates aldehyde from alcohol. Probably, if I'm not mistaken, it's due to oxidation. Basically, aldehyde is oxidized alcohol. Now, moving on, we have our third, which is ketone, and our fourth functional group, we have ether. So, for alcohol, we have to, in order to memorize, I just wanted to show you that alcohol is just like this. The structure has 2 carbons, and again, on both carbons, they have lines reaching to its up, down, right, and left. So we'll be filling everything with hydrogen except for this right side. For the very east of the entire structure, we'll be having O and H. So this is what defines alcohol. OH, oxygen and hydrogen mixed together as an organic compound. Now, for aldehyde, again, we still have 2 carbons, just like alcohol, because again, alcohol is closely related to aldehyde, apart from one difference, which is oxidation. They still have 2 carbons, and they still have hydrogen at the very left of the left carbon, similar, but this time we have this kind of difference. So we have hydrogen at the northeast, And at the southeast, we have oxygen, which is bridged with a double bond. So one thing that we have to remember in terms of aldehyde is this part of the structure. Again, these structures that I'm illustrating right now, I really encourage you to memorize these, but mostly you'll have to memorize the correlation of, for example, for aldehyde, um, carbon, hydrogen, and oxygen should be drawn this way, because this part will never change regardless of how different the structure is. Whenever you see this kind of combination, you already know which functional group that is. So in this case, it's aldehyde. And for this, OH, you already know that it's alcohol. So moving on, for ketone, we have 3 carbons this time. We don't have 2 carbons, but 3. So we'll make this kind of structure, assuming or imagining that these lines are scaffoldings, if you know what I mean in Minecraft. But games aside, C, 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 and we place H everywhere. We connect them, and this time, at the very middle, at the very center, we place a double bond symbol, and we place O with 4 dots at at the edges of oxygen. I'm not sure what that really means in a personal level. I've not really studied much about this, but this is the structure. I can tell you right now that this is the structure for ketone. You have to remember that C, H, and O are linked together in that kind of respect. So that's ketone. Let's move on to ether. This time for ether, we have 4 carbons, but there's a big gap in the middle. That would be our oxygen, with again 4 dots. I can't really be certain if ketone and ether are related, but in terms of their structure, they might be related, knowing that they both have carbons, hydrogen, just like any other functional group that we studied earlier. But they both have the oxygen with 4 dots. And yeah, that's the reason why I'm suspecting that ether and ketone are related. But of course, it's unproven yet. It's up to you to make the further research in regards to that. Anyways, this is how we draw the structural formula. I mean the structure of ether. Basically, we have 1 oxygen with 4 dots in the middle. Everything else, it's drawn that way. Just one fun clue that you might want to use in order to memorize what ether is as a structure. Just imagine that these are buildings. I know it's weird, but it might help, I hope. And just imagine that this is a Ben 10 watch, the Omnitrix. It does look like an Omnitrix, doesn't it? And yeah, that's ether. And for ketone, just imagine Loki's scepter. And this is the Tesseract. Anyways, fantasy aside, yeah, ketone, this is what we have to remember. For ether, an oxygen with 4 dots. Alright, let's move on to the next chapter. I'm not sure which noun is going to classify this, but what I know is that there are 2 acidic functional groups and there are also 2 basic functional groups. For acidic, we have carboxylic acid and ester. We'll just move ester below. There you go. And for basic, we have amide and amine. For carboxylic acid, we have 5 carbons. 1, 2, 3, 4, 5. So we place it in that kind of structure, and everything else just like a pizza party that one usually attends at school in celebration of a classmate's birthday. This is how things work. Imagine the carbons being the birthday table, and the classmates surrounding the table being the hydrogen. And this is not going to be an accident. Imagine that this carbon, the fifth carbon, at the very right, is going to be the birthday celebrant. And this is going to be the lighter and the birthday cake. I'm expecting that you won't understand my imagination, but I hope you also find a way on how to memorize this kind of structure. Just remember this part of the structure and you'll be fine. Note that we have OH, alcohol, and oxygen with 4 dots. That's what defines carboxylic acid. By the way, let's change style, change color. There you go. For this chapter, let's use brown. For ester, we have COC. This is the basis of the entire structure. For ester, just always remember Clash of Clans, COC. Carbon, oxygen, carbon. This is the pillar. This serves as the pillar for the structure. And place hydrogens surrounding the carbon here at the very right. And another carbon there, another hydrogen, another hydrogen there, and here an oxygen. So place a double bond symbol and place the oxygen there. Now this is Esther, not the person in the Bible. This is a chemical compound. You could also use the personality in the Bible, the real life Esther. If it does help, I suppose you could use that terminology in relation to this. Esther, literal name, and COC. So yeah, let's not make fun of references. Let's just use it so that we could memorize. There's no intention to make fun of it. We only intend to memorize, so that using those references. Let's move to the basic functional groups. So for amide, we have to note this kind of abbreviation. So H sub 3C, we have to know that term. When we see this particular term in a structure, you might already have a clue that it would be amide, a basic functional group. But that's still it's still insufficient to really assume that it's amide. So we have to determine if there is what we call CNNH. And imagine that CN would be an abbreviation for anything that is abbreviated as CN. For example, what I have in mind is Cartoon Network. So Cartoon Network and NH. NH, it's up to you in terms of how you want to remember that for. So the important thing is you have to know that it's CN and H. Now for the structure, provided that we have these ideas, we start with H sub 3C, and one line up we place C, one line down we place N with 2 dots at above the network of Cartoon Network, and we place 2 arrows north, east, and south. At the south we place H, at the northeast we place N. So as you can see, you might see the pattern right now. CN and H. CN and H. In that case, we could also derive that H sub 3C is going to be the starting line. Now, our structure is not yet done. Above carbon, we place a double bond symbol and place O with 4 dots, oxygen. So this is amide. It may look complicated at first, but if you really, if you can memorize, or if you can really recognize, these terms, if you can remember that it refers to amide, you might have no problem anymore. This is going to be a piece of cake for you. For those who still cannot understand, I suggest that, just like any other suggestions after teaching something, the teacher really advises the student to practice, to, in this case, redraw what is being illustrated right now. Yeah, that's everything that I have to say right now. For amine, the second basic functional group, we have 2 carbons, basically. So yes, this is again our basic outline. H, 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 H. And at the very right, we have NH sub 2. That's it. Piece of cake. So that refers to amine. NH sub 2. Now, we're almost done with our lecture. We still have 2 ideas that has to be discussed about. We have cyclic. I'm not sure if it's cyclic. Give me a few seconds to recalibrate what I know. Okay, I'm correct. The spelling is correct. Cyclic. I just have to introduce to you 2 chemistry compounds. One is cyclic and one is aromatic arene. So, for cyclic, basically our illustration is, if you've known about this specific snack called piatos, this is where the hexagon comes in the picture. So cyclic basically has a single bond. As you can see in this hexagon, or this potato chip, potato-like chip, there is no illustration like this. Neither does it have like triple bond. It's all clean. It's all one clean single bond. Anyways, that's everything that we have to know. One example for cyclic is the cyclohexane. Hex being provided that we have 6 sides, or 1, 2, 3, 4, 5, 6 carbons, and ane because it's single bond. And it's cyclo because it's cyclic. Now, let's move on to the second, actually the last in this lecture, the last compound that we're going to discuss. Aromatic arene is still a piatose chip that has a double bond. So in this case, we have carbon, 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 and in extension to that, we have hydrogen, 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 hydrogen. There are 2 basic characteristics of that defines aromatic arene. Aromatic arene is super stable, and it's really defensive against chemical attacks. So, One example for aromatic arene is the benzene ring. So yes, this is everything that we have to know for functional groups. Again, I I can assure that this video is going to be incomplete. What I am teaching right now is, so I'm expecting that this lesson is going to be incomplete in terms of the functional groups. I may or I may or may not be able to discuss in this video everything that is in store for this lesson generally. But this is what we have learned at school, and yeah, I just wanted to share these all to you. Thank you for watching this video, and I hope you have learned something. Please prepare for your exam. Whatever your test is, I wish you the best. Thank you.